array and the min k value and max k value, we need to find out how many subarrays we could generate where the minimum value is equal to min k, maximum value is equal to max k. So if you see, in a brute force way, we can generate all the subarrays, and we will see whichever subarray is having min k and max k is equals, so we can return that count. In this case, the expected output is 2. If you pick up any other subarray, it doesn't have these two values, satisfying these two values, so that you can ignore them. Right? So now problem statement is clear, right? Ajay, Kalyan. Kalyan, is it clear? Okay.
Yes.
Now, how do you want to implement this? The brute force you understood, na? Brute force is very simple, right? So we can generate a.
Generating subarrays and then checking those values in the subarrays.
Make sure that in the subarray the minimum value should be 1, maximum value should be 5. Right?
Yes,
So that
got
way
it.
you can generate a. Yeah, so that way you can generate a count. Okay, so then how do you come up with optimistic solution? Okay, so for this solution, so let me write a brute force. So that will help us to generate a come up with the optimistic solution. So let's see what can we do. Okay, so what is our job? We'll have start. So you can have I, you can take I, so which is 0, and I less than nums dot length, I plus plus, and for int j equals 0 and j less than j equal to I. So that's how it is working, right? So j less than nums dot length, j plus plus. Okay, so now what we do, let's take it is expecting in the form of long, right? So let's take long count, which is equal to 0 initially. Now let's move on. So what we do, we need a minimum value. So let's take min. It is integer array, so that minimum value we can take it as a integer dot max value. Similarly, we want to find out max value, so that integer dot min value. Okay, so what we do, first we will just whatever value. So generally how it works, so initially it is 0, then it is going to be 0 comma 1, then it is going to be 0 comma 1 comma 2. So that's how it is working, right? So that the j is talking about all these things. Yes or nobody? Correct? Correct?
Yes.
So what I'll do, I'll just take min equal math dot min of whether it is current min is valid, or whatever nums of j, is it minimum, so you will consider that, and max equal math dot max of current max is max or nums of j is max. So we will find out min value and max value. And if you closely see, right, if you closely see, okay, didn't I open this? Okay, so if you closely see, in this array, right, in this array, you can blindly ignore these parts, right? So you can blindly ignore these parts. Yeah, so if you closely see, in this array, right, in this array, you can blindly ignore these parts. Why? How do you say that you can ignore these arrays?
Because there are elements which are
The
greater than
maximum
5.
element, right? So the max element
Yeah.
is greater than 5, right? If there are
Yeah,
minus 1 here, then you can also ignore this, because this is less than min, right? So what you can do, you can ignore continuing further, right? So when you find, for example, here you find, let's say here you found an invalid value. So whenever you find an invalid value, you don't have to continue this, right? You don't have to continue this, because whatever element starting with, whatever subarray starting with this element, definitely going to be invalid. So that just to optimize this, what I will do here, so if min is less than whatever min k is present, so whatever min k, or max is greater than whatever max k, then you don't need to continue subarray starting with 0, right? So that you can simply break it, correct?
Yes.
Now when do you make a count? So when do you make a count? So if min is equal to min k and max is equal to max k, you can make a count, so that you can simply increment count plus plus, correct?
Yes.
So this is simple code, right? So obviously what is the time complexity here?
N square.
So definitely it is n square. So if you return, so this will work, the brute force approach, but if you submit it will definitely fail, because it is n square. Now by looking at this brute force, right? So what is the optimization we wanted to do? So let me take you to the another and one more complex input. Then let's say you have 1 5 3 2 5 1 7 1 5. Okay, so then here the min k is equal to 1 and max k is equal to 5. Can you tell me how many subarrays you can generate? Valid subarrays. Looking at this code. Uh, Let me note down. So is it valid?
Yes.
1. Okay, is it valid?
Yes.
2.
Yes.
So this is also valid. 3, right? And this is also valid, correct?
Yes.
Right. And this is also, so let's say, let me note down. So there are, you will get lot of things. Let's see. So one is 1 5, other is 1 5 3, correct? Other is 1 5 3 2, because you can extend till here. Now yeah, so next one is you can extend till here. So 1 5 3 2 5. Now if I extend here, right? If I extend here, closely understand how many I would get. So one is 1 5 3 2 5 1. So this is perfect. And what else I would get? I can make this is valid with these two combinations as well, right? Yes or no, buddy? Yes
Yeah.
or no? So with this combination also I could make this is valid, right? Yes or no? So with this combination I could make this is valid. So that means 5 3 2 5 1, right? Correct na? Correct na, buddy, please. And
Yes.
uh, even uh, even so with this combination also I could make 3 3 2 5 1, 3 2 5 1 also valid, and 2 5 1 also valid, because you keep on getting this, right? So 2 5 1 also valid, and again 5 1 also valid, right? So 5 1 also valid. So closely understand. So this is what we did, right? So if you have a, this is a sub array, then 5 1 is valid, 2 5 1 is valid, 3 2 5 1 also valid, and 5 3 2 1 5 1 is also valid, and 1 5 3 2 5 1 also valid. So that's how we generated all these formats. Now if you go further, if you include this element, then none of these subarrays are valid, so that you can directly have this one, so which is going to be, and this is also valid, so which is 1 comma 5, right? So let's see how many we generated. So 1 2 3 4 5 6 7 8 9 10. So let's count this. Let me input this 1 5 2. Let me input this. So 1 5 2 2 5 1 7 1 5. So if you closely see, for this test case we got 10, right? So now what did you understand here? What did you understand by looking at this input? Can tell me?
If you get a subarray having min k and max k and there's no invalid elements in between,
Mm.
then one go itself, I think we can get the number of subsets.
In one go, but if you closely see, this is giving complex count, right? So
Correct.
how do you handle this count? So generally, when you are working on this, right? So when you are working on this, uh, when you are considering these two elements, right? So you should not consider these two elements as part of generating survey. If you want to know the max count, right? So if you consider this one, if you know this 5 1, then this 5 1 can be part of these four elements, right? Yes or nobody? Please closely understand. We got count as 10, right? So first count is what, this one, right? 1 5,
Yeah.
correct?
Correct.
So we got first count as 1 5, okay? So 1 5 we got with as count 1. Then if you closely see, when I am further extending here, so I got second count as 153 and third count as 1532, right? So it means starting with 1 5 I got two more possibilities, so that I got 3 here, correct now? Till now it's clear, right?
Yes.
Now let's move on to this. When you are checking on this 5 1, right? When you are checking on this 5 1, so this 5 1 is valid, perfect. So I take that 5 1, this 5 1 is valid, I can take that 5 1 plus this 5 1. Closely understand, this 5 1 can be valid for these four elements or not? Yes or nobody? For these four elements or not? So 2 5 1 is valid, 3 2 5 1 is valid, 5 3 2 5 1 is valid, and also 1 5 3 2 5 1 is also valid. With this 5,
Correct.
for this 5 1, these four elements also valid, right? Yes or no?
Yes.
So that I can take plus 4. Okay. Then finally, what else you have? And this one, right? So 1 5. So 1 5 is valid. So which is 1. Total we got which is missed. Okay. So we missed one more thing. Uh, we closely see this 1 5 can be extended till here, right? Yes or nobody? This
Yes.
1 5 can be extended till here, right? So we extended only till here, but this 1 5 can be extended till here, so that for this 1 5 you get three elements, so that's where we got the miss. So this is 3, and total you got 4 plus 5 plus 1, so total you got 10, correct now? So now let's understand how to build the logic here. Do you understand what I said, Kalyan, Ajay?
Yes.
Okay, let's try to build the logic. So let's see how do we want to build the logic. Okay, so let's move on. One thing for sure, we need to know what is the minimum element and what is the maximum element, right, within a window. Yes or nobody? Yes or no? So first of all, this is my indexes starting from 0 1 2 3 4 5 6 7 8, correct? Right. Now I want to find out a minimum element and maximum element within the window. So then what should I do? Can you tell me with your knowledge? One thing for sure, what is the minimum element? What is the maximum element? I need to know, so that I can understand that this window is valid or not. Correct na buddy? Ajay, Kalyan.
Yes.
Then what should I do to know minimum element and maximum element? Ajay, what should I do?
If you know the minimum element and the maximum element,
Mm.
if any element comes in between that range, then that's valid. If any element comes outside that range, it's invalid.
Outside also it is valid, right? Even outside also it is valid, right?
I mean, let's say here the maximum element is 5. If 7 is coming, then that's invalid.
Yeah. Even if it is in the middle, outside or whatever it is. Yeah, correct. Yeah. One thing for sure, I must and should know. In constant time, I should know what is the minimum element and what is the maximum element with respect to current window. How should I know that?
I think we need to use min heap and max heap, right?
Yeah, as we don't know heap concept, can we have alternative?
I mean, in DQ you can do that, right? The
Yeah.
first in a non-decreasing
Yeah, so we
alternate
will
DQ,
have
the first
two
element will be the
queues.
highest and rest all gonna be smallest.
Yeah, so one is min q, another is what, max dq.
Yeah.
Okay, so let's see, let's handle with this. So we have one min dq, another one is max dq. Okay, so I am at this element. Okay, in the dq I will only maintain indexes. Okay, you will get to know why. So in the dq, so I have, what I will do, first row both the dqs are empty, right? So what I will do, I have value 1 which is at index 0. So same element also be added to the second dq, so which is max dq, so which is 0, which is at index 0. Till now it's clear, na?
Yes.
Now let's move on to the next element. Now let's see, so if you see that, what is the minimum element and what is the maximum element with respect to this? One
Same
only, right?
element.
One only. So but it is satisfied minimum, it didn't satisfy maximum, so that let's move further. Okay, I'm going on to the next element, 5. So when, what is a min dq property? So the element should be in so in a min dq, what we do, the elements will be in increasing order, right? Okay, what's happening? Okay, so in the min dq, what we do, the elements will be in increasing order. In max dq, the elements will be in decreasing order. Now next element is, I am trying to process next element. Element is 5, which is at 1. Okay, so which is at 1. So let me do this way. Next element is 5, which is at index 1. Now in the max dq, of course the element is greater than this, so that I don't delete the previous element, because min dq maintains the property of the first element should be minimum. So when it comes to max dq, right? So I am trying to add the element which is 5, it is at index 1, but the current element is greater than previous element, so that I will delete this, because it's a max dq property, right? So that in the max dq right now you have only one element which is 5. Correct na? Correct na, buddy?
Yes.
So now let's understand
But same goes with min DQ also, right? So when
what
we
is the
have
property of min dq. We should maintain minimum element in the first, right?
yes,
Yeah, so when you are trying to add the current element which is greater than previous element, right? So that this is valid, right? Min dq maintains the property of keeping the minimum element at first, right? How do
take
you
first.
delete? How do you if you delete this is going to be maximum, right? In this current window, the minimum element is 1, which I am getting from min dq. The maximum element is 5, which I am getting from max dq.
Okay, but why to add 5 at what first index in min DQ? Anyway, we have one, right?
How do you know that? How do you know that?
Mm-hmm. Okay, when we compare, then only we'll get to know which is minimum. Correct. Yeah. Got it.
Okay, so let's move on. I understood your point. Let's, you will get to know once we are moving on. So this element is deleted from the max dq. In the max dq you have element 5. Now let's move on. Now you see, what is the minimum value you got? 1, right? Correct? What is the maximum value you got? You can get from the max dq, which is 5. So which is
12 first.
satisfying the
Yeah.
principle, right? Now we need to update the count, correct? We need to update the count. How do you update the count? How do you know the count? Right? How do you know the count? So earlier count is 0, so there is no count. So what we can do, what we can do to know the count, what we can do, okay.
No, whatever the element we pull from the DQ, if it is within
No,
the
no,
range of 1 and 5, then we'll increment the count.
no, that will not work for this, right? When it comes here, you will get to know that, because that will not
Okay.
work for other things.
The range
Yeah.
situation, yeah. Got it.
So just a minute, I want to find out a count. For sure I must and should consider minimum index out of these two, because from where from where it is starting, right? Yes or nobody? From where the subarray is starting, that one I should consider, correct? Correct, nobody? Subarray is starting from index 0 only, na? As of now.
Yes.
So means you should consider the starting point minimum of these two. So minimum of these two is going to be 0, 0 and minus just a second. Perfect. So what I will do, let's understand, I will maintain last invalid index. Okay, because this is very important when you come here. So when you come here, right, if you closely see, when you come, let's say when you come here, this is invalid index, nobody, yes or no?
Yes.
This is invalid index, right? Now when you try to compare next elements, you should compare, we need to consider minimum of these two. The minimum of these two is 7 minus what is the last index, invalid index? 6, 7 minus 1, so which is going to be 1. It means you can generate one subarray here, yes or no? Correct, nobody? When we are processing
Yes.
on, so you will find a last invalid index here, right? So let's say right now the last invalid index is 0. Okay, now the last invalid index is 0. Let's not take 0, so let's take minus 1 for the first time, because there is no invalid index, right? When you are starting, there is no invalid index, so that minus 1, so that it will satisfy the principle. So what you do, so you need to consider min of these two. So how do you find out the count? So count is equal count plus min of what is the value you have. So 0 comma 1, so these two indexes, 0 comma 1 index minus last invalid index. So in this case count is 0 plus min of 0, 0 comma 1 is 0 plus minus of minus 1, so which is going to be plus 1. So that count becomes 1. Is this clear, buddy? Is this clear?
But how to come up with that formula?
Yeah, how to come up with that formula, right? So first of all, first thing is, why do we need to know min of these two indexes, right? 0 comma 1, why we should consider min of these two indexes? First of all, why we should consider this, right? First thing is you need to know, is it valid subarray or not? If it is valid subarray, how do you know that? If it is valid subarray? If the subarray minimum element is equal to min k, maximum element is equal to max k. So in this case, which is valid, correct?
Correct.
So which is valid, fine. Now it means if it is 1 comma 5 present in the subarray, doesn't matter. If 1 comma 5 present in subarray, doesn't matter, it is valid subarray. It can be any elements going forward. Right now we have only 1 comma 5, correct? Correct, nobody?
Yes.
So even in going forward, you can have x1, x2 elements, doesn't matter. As long as these are not exceeding these values, then it is fine. Now, let's say in this case, we have 1 is at 0th index, 5 is at first index, right? So you have 0 comma 1. So 0 comma 1. So it's time for us to, so now it's time for us to find out subarray. So the subarray is starting from minimum index of these two. So the minimum index of these two is going to be 0. Okay, so minimum index of these two is 0. Then the last invalid, so more importantly, we need to know that what is the last invalid index. For now, initially we don't know that any index is invalid, so that we can mark it as minus 1. So you can consider min of what are the indexes you have. So right now the indexes are 0 comma 1, then minus last invalid index, so which is going to be minus of minus 1, so you will get plus 1. Okay, now why I come up with this last invalid index? So by considering these two elements, so when you are at last, right, so you will have a subarray 1 comma 5 again, their index is 7, 7 comma 8, so 7 comma 8 the minimum value is 7 minus, when you are here, the last invalid index value becomes 6. Why? Because 7 is out of the range, so that it's 7 minus 6, which is going to be 1, so that I can able to calculate 1 here. Do you understand what I'm trying to say?
Yes.
Kalyan?
Got it.
So now let's move on. So okay, so yeah, so let's move on. Now when I'm moving on to the next element, okay, so let's move on. Right now the count equal to 1. So what is the formula for count? So count equal count plus math dot min of indexes. So index 1 comma index 2 minus last invalid index. Okay, so this is a formula. So this you can generate by looking at the input itself, right? So now let's move on to the third element. So when you are moving on to the third element is 3, correct now, madam? Third element is 3, correct? Correct. So
Yes.
now let's say you have 3, so which is at index 2. Now you want to maintain a min dq, right? So definitely the previous element is larger, so that you will remove it. Okay, so you will add both the elements in the both the dqs, but when you add max dq, the current element is less than previous element, so that you just keep it. But when the current element is when it comes to min dq, so the previous element is larger, so that you delete it, so that the current element goes to the second place. Okay, fine. Now again apply the same formula. So in this case, if you closely see here, so let me say, so here the current count is 1 plus min of 0 comma 1. So it means the first element thrown in, so you will consider first indexes only. So min of 0 comma 1, so current count is 1, min of 0 comma 1, so plus, sorry, minus last invalid index minus of minus 1, so which is going to be 1 plus 1, so which is going to be 2. So it means the count is going to be 2 now. Is this clear, buddy? So
Yes.
now more importantly, why are you adding count? Because why are you adding count? So because whatever count, whatever subarray you are going to generate, right? For that subarray, the previous count also will be appended. So that's why you will add the count. Fine. So let's move on to the next element. Now next element is for 2. Okay. So let's move on to the 2. So again, you will try to add 2 both the places. Here also 2 at index 3. So here 2 is valid because 2 is less than 3, so it is valid. But when it comes to min dq, 2 is less than 3 because min dq follows the min property, right? So that you delete the previous element. So definitely 2 goes first. Means 2 goes here. You cannot delete 1 because 1 is smaller than 2, so that again it is satisfying the same principle. The first minimum value, the first maximum value, both are is equivalent to min k and max k. So it's time for us to increment the count again. So if you apply the count again, same thing, current count is 2, and again you will have 0 comma 1 minus of minus 1, so again you will get 2 plus 1, so which is going to be 3. So count becomes 3. Perfect. So let's move on. So count is 3 now. Now let's move on to further. So when you go to 5, so now when you go to 5, so this is where you will find the importance of dq. So when you go to 5, so here I am keeping 5 as which is at 4th index. Now let's move on. So if you closely see, if you add 5 at index 4, right, it is at index 4. So definitely this is smaller, so delete it. This is smaller, delete it. This is also equal, so that you can delete it. So if you closely see, all the elements got deleted. All the elements got deleted, so that it is going to be still the my maximum element is 5, minimum element is 1, but what is changing? Only the index is changing. So closely understand, only the index is changing. So let's move on. So now again apply the same formula. So current count is 2 plus max dot min of 0 comma 4, right? So min index value is 0, max index value is 4, and minus of minus 1. Again it is going to be 2 plus 1, so you will get, sorry, earlier 3, right? So 3 plus 1, so you will get 4. Now current count is going to be 4. Perfect. So now you will understand the importance of dq. So now let's move on to the next element. So when I move on to the next element, so here I am. So when I am moving on to the next element, so here I am, so that I am trying to add 1 which is at index 5. Now here also 1 which is at index 5. So with respect to max dq, it is valid. Now when it comes to min dq, so current 1 which is greater than, which is less than previous value, less than previous value, less than or equal to previous value, so that all the elements will get deleted. All the elements will get deleted. So now 1 is here. Now let's understand what is the, so now let's apply the formula. So current count is 4 plus min of indexes, minimum value is at index 5, maximum value is at index 4, so minus last index minus 1. So 4 plus minimum of these two, which is going to be 4 plus 1, so which is going to be 9. So definitely this is going to be 9. So what is going to happen here? Now when you come to this place, right? So when you come to this place, in the min dq you will have only these two elements, 5 comma 1 priority elements. So you will find minimum of these two, 4. It means this 5 1 can be mapped with these 4 elements. Correct now, buddy? Yes or no? These 4 elements plus this phi 1 can be mapped with these 4 elements, plus this phi 1 can be part of these 4 elements also. That's why you will have this phi 1 can be independent, plus this phi 1 can be mapped with all these 4 elements: 2 phi 1, 3 2 phi 1, phi 3 2 phi 1, 1 phi 1 3 2 phi 1. That's why you got 4 plus 1, so which is going to be 9. Is this clear, buddy?
Yes.
Ajay, clear?
Yes, true.
Now let's move on to the next test case. So now you are moving on to the next element, so which is 7. Okay, so 7. Now what is our time? So now this is where you need to apply intelligent thing. So now the current element is 7, right? So listen, current element is 7, which is greater than max k. So when it is max k, now whatever prefix values you have, right, doesn't matter. So current element is 7, right? So current element is 7, and whatever prefix value you have, any prefix, if it is adding to this element, right, it is going to be invalid, right? Yes or no, buddy, please?
Correct.
Right?
So we need
So
to
it's
remove
time
everything
to,
from the DQs.
yes, so it's time to clear DQ. Okay, so it's time to clear DQ, and it's time to update last invalid index to, what is that index number? 6.
6.
Perfect. So we added last invalid index to 6. Perfect. So now let's move on. Let's move on. So now you are going to next element. So it is index 7. So index 7 having value 1. It is at index 7. Here also value 1 at index 7. Now move on to index 8. So at index 8 you have value 5, which is at index 8. Here also you will have value 5 at index 8. But this is greater than this, so that you will delete it. So that our max DQ contains 5 comma 8. Is this clear, buddy? Is this clear?
Yes.
Now it's time to find out, apply the same formula. So the current count is 9 plus minimum of these two indexes. The minimum of these two indexes 7 comma 8 minus last invalid index, which is 6. So when it comes to 9 plus minimum of these two 7 minus 6, so which is going to be 9 plus 1, so which is going to be 10. So 10 is our answer. So we just need to return 10. So what is the time complexity, buddy?
Order of n.
Order of n, right? So what is the space complexity?
Just two DQs. Anyways, that will be very smaller than the n for sure.
So you can say order of n, right? So almost, right? So first of all, don't by heart this formula, okay? So if you by heart this formula, gone. Now how can we build that formula? Hope you are able to understood, right? So let me write the code. Or do you have any questions on how to build?
I mean, overall concept you understood, the only the critical part is that formula. So
No,
once
how
you
do
write it and when you run it through that example, then it fits it properly well.
Yeah. Otherwise it won't.
Yeah. Correct.
Otherwise it won't. Yeah. Okay, so actually, yeah. Let's try to implement that. So you have long count, which is 0L. Okay. So there are DQs. So you have min DQ. You also have max DQ. These are very complex problems. It's a new way of pattern, right? It's like even you know knowledge on DQ. Yeah, getting into that is really tough thing. Okay. So what is our job now? So for, and we also know last invalid index. So initially we mark it as -1. Okay, so for integer I0, okay, what do you do? Okay, so index which is 0, index less than nums dot length, index plus plus. Okay. So now let's move on. So first what we do, if nums of index, if it is less than min k, correct? Or if it is greater than max k, it is a invalid, right? Yes or no, buddy? Correct, na? If it is the case, the current index is invalid, right?
Yes.
So either of the case, so that what you do, first you update.
Should know that would be greater than, right? The second condition.
Yeah, it should be greater than, yeah.
Yeah.
So if it is the case, you should apply last invalid index is going to be current index, and whatever you have on the min dq, you can clear it, and max dq also you can clear it. Perfect. Otherwise, so what is our job? It's time to update the dqs. So how do you update it? So while my min dq is not empty, and in the dqs we will only maintain indexes to find out the counts, and whatever value, so current index value, right? So nums of index, so this is my current value. If it is less than or equal to nums of min dq dot get first, so whatever first element present in the dq, if it is less than or equal to current element, so you can simply delete it from the min dq. Correct, nobody? Is this clear?
If it is less than or greater than, if you know.
Min dq, right? Min dq means what? You should have a minimum element at first, right? If the current element is minimum than element present in dq, you should delete it, right? For max dq it is reverse, right?
Right. Yeah. Correct.
If it is max dq, if the current element is greater than or equal to whatever element present in max dq, so you can remove it from the max dq. And finally, you will add current element min dq dot add of index, comma max dq dot add of index. Correct? Now how do you know that it is valid window? Till now we set up the dq, and how do you know that it is valid window? Kalyan? First of all, I am not understanding.
If that element nums of index is within the range of num k,
So
sorry,
it
max
means,
k and min k.
yeah, in the min dq dot get first is equal to min k, correct? And nums of max dq dot get first, if it is equal to max k, then it is valid, right?
Valid window, yeah.
So if it is
That
valid
time
window,
we'll make the count, yeah.
yeah, so we will make the count, right? So how do you make the count? So you will take count is equal to count plus math dot min of min dq dot get first, comma max dq dot get first, and minus last invalid index. Yeah. So finally you can return count. Okay, so most critical part is this one.
So, you know, one thing, I'm still confused on line number 16. I was thinking the condition would be nums of index is greater than equal to min q dot get last.
No, why? What do you want to maintain in min dq? Min dq?
In the first element should be smaller, rest all can be bigger.
Yeah, that's why, right? So let's say in the min
Yeah.
dq you have element 1. Okay.
Correct.
Current element is 5. Then what you will do?
Just append it.
Append it. So what it does?
Nums of index is 1.
Nums of index is 5.
Yes.
Yes, nums of 5. 5 is less than first one, no. Okay, it does append it, correct.
Correct, right?
Yeah, it doesn't go inside, doesn't remove anything, yeah, correct, yeah.
Counter spelling wrong.
No, we count and counter, we have kept two things there.
let's say what is the mistake we did. It's giving count as 9 rather 10, so let's move on. This is fine, this is fine. Okay, for our input only it is failing. Why? While walking through it, we could able to figure that.
One question, that while condition what we wrote, right? Generally, we compare it with the last element in the monetary queue, right? Not the
That's
first.
correct, buddy. Yeah, that's correct. So we compare with last element, no?
Yeah.
Yeah, it will work. Remove last, right?
Remove last, yeah.
Yeah, that's a game changer.
No, there's still something wrong.
This will by default add to last. Min k, max k. Then we consider minimum of this last.
Shouldn't can you go to the condition again, like code? The last line, 31.
Just a second, let me copy this input.
Yeah.
Mm. 31.
We are counting the minimum there, right?
Minimum.
Is that the correct condition? I feel like it should be max, right?
No, it should be minimum, right? Starting point you should consider now. If you say this, max is 4, min is 0, right? In this case,
Yeah.
so you should consider minimum point. Let's figure that out. What is the mistake we did? One 5 is fine. Let me do one thing. I will try to print index and the counter. So 0 At 0 it should be 0. Okay, let me take ours. Why this is not coming up? Okay, and let me take this guy. Okay, it went 7. Why didn't go to other indexes? Let me check. It went to till 7th index only, right? But how many indexes we have? Till 8. So why it didn't go to 8th index? When it goes to 8th index, yeah. So tell me, bro, what is the mistake we have done?
I think at line number 10, somewhere it is going, not going inside. And it's getting inside, cleaning it up.
So if you close this, oh no, I think we have added.
Oh, we have it.
8th it is fine. 1, 2, 3, 4 is fine. When it comes to index, let me add. So when it comes to 8, the count didn't change. Why? So till 7 it was 9. When it comes to last index, count didn't change. Okay, so where are we adding that? Just a second. Did you understand the issue? So at last index the count didn't change, right? Ideally it's supposed to
Yeah.
change. So it was correct till index 6. And after that index 7 and 8 it didn't change. So let's add these DQs also. This is max DQ. It's okay to get issues. So we have done some slight mistakes, so that is causing the issue. Okay, max DQ has, yeah. Tell me, buddy, what is the issue we did?
Yeah, adding that index to the DQ.
You know what is happened? What happened? Uh, what happened? Tell me. So it's a critical case, man. So it's a critical case.
So in the max DQ, basically we expect the maximum to come to the front.
Mm. But what is in the sixth position we have element 8, element 7, which is present
Six
in
would-
max DQ. At index 6 we have element
Oh,
7.
right. Got it. That's an invalid element to be in the DQ itself.
DQ, right? So what should we do now?
We should put a condition like what the element is coming, that should be between that max and min k range only.
So actually when you get this one right, you should not go further. So you should do continue, right? Correct now. Otherwise what will
Yes.
happen? Current index will be added to both the DQs.
DQ is correct.
Would not be added.
That is causing the issue. So it's very we didn't talk in
Tricky one, yeah.
algorithm, but we come up with very good test case. But now you understand So can we solve it? Can we solve it without what do you say? Without space, right? So let's see how do we solve it without space. Now we know the concept, right? Yes or no, Ajay Kalyan? Now you know the
Yeah.
concept, right? What is the problem? So now let's move on. Do we really need? Do we really need? Uh, yeah. So do we really need DQ? Do we really need DQ? As per this concept, so what we did, so one most important observation is minimum element should be mapped to the latest min index, correct? Maximum element also should be mapped to the latest maximum element, correct? Nobody, please.
Yes.
Minimum element, so if you closely see here also you have minimum element and maximum element. When it comes to here you will understand better, right? So here max, here is min, it is also present, but max index should be mapped to the latest max, min index should be mapped to the latest min, which is clear, right? Yes or nobody?
Yes.
And last invalid index as usually it is -1. Okay, perfect. Now let's move on. So let's move on, how can we do that? So what I'm going to do is I will have two indexes. One is min index, another is max index, and I'll also have last invalid index. Okay, so which is going to be -1 initially. So now let's move on. I am at this one. So you also have a min k is 1 and max k is 5. Okay, so let's move on. I am at this index, the min index. So yeah, so okay, so first of all we will consider min value as max, and max value, there are two values, so max value as min, some integer dot max, integer dot min. Now if you closely see, when you are here, the current min value is higher than this, so that you will update this, and you will also update the min index. So min index is going to be current 0. Similarly, when it comes to max value, current max value is minimum, but the current value is 1, so which is valid, so that current max value you can take 1, so and you can also update max index as 0. Is this clear till now, please? I am taking, okay, additionally you don't need to worry about these values. Let's say initially the min index and max index is going to be 0th index. Is that clear, Ajay?
Yes.
Yes.
Okay.
Yes.
Why are you?
Can you hear us, Shinu?
I can hear you, but I want to see this window. Yeah. So initially min index and max index is remains 0, so no worries about it. Last invalid index is -1, so you are at 1. So yeah, so you are at 1. So now let's same concept. So current value is invalid or not. So current value is 1, valid because it is within the range, so that there is no change in last invalid index. 0 0 as usual. Now when you move on to the next index, current min, in the min index, right? So you have value 0, value, so this is index, okay? So it is index 0 pointing to 1, so that this is minimum with respect to 5, so that there is no change in min index. When it comes to max index, you have a 0th index which is having value 0, but the current value is 1, so that which is higher, so that you will update max index equal to 1. Is this clear till now?
Yes.
It's a simple math dot min, math dot max, that's it. Okay, so earlier in the max index you have value 1, but current value is higher, so that you will just update. We will maintain indexes, not the values. Okay, so for your clarity sake, here it is 1, here it is 5. Now if you closely see, both the values satisfying the rule, right? Yes or nobody? Yes or no?
Yes.
Yes.
So now it's time for us to update the count. Same concept. So count equal count plus math dot min of these two. So 0 comma 1 minus of minus 1, so last index, so same concept, so 0 plus 1, so which is going to be 1. Now count becomes 1, same concept, so right now count becomes 1, right? So what is the formula we are following? So count plus math dot min of indexes I1 and I2, then minus last invalid index, right? So let's apply the same formula. Now it's time for us to move further. So when you come here, if you closely see, do you see any change in min index and max index with respect to this element? No change, right? Yes or no?
Yes.
Ajay Kalyan, Ajay Viru. Current
Correct.
element is, so there is no change. Apply the same formula. Earlier count is 1, again you will get 1, which is going to be 2, because again 0 comma 1 difference is 0, then minus of minus 1, which is going to be 2. Now when you come here, and still there is no change, right? So this element also doesn't affect these two fields, so definitely this is going to be plus 1, so you will get 3. Now when you come here, do you see any change again? Do you see any change, please?
The max index will change, right?
Right, so right, max index, if the, yeah, so you just need to update, you will just check if the current element is greater than or equal to max index value, so that you will just update the max index, okay? But still you see it is satisfying these principles now, yes or no?
Yes.
So now it's time for us to update the counter plus math dot min of both the indexes 0 comma 4 minus of minus 1, which is again 1, so 3 plus 1, so you will get 4. Okay, now let's move on further. So when I move on here, so what is going to change, tell me please?
Min index.
Min index will change,
Five.
right? So which is going to be, which is at index 5 having value 1. Now again it is satisfying the principle now, yes or no?
Yes.
So now it's time for us to calculate the answer. So 4 plus min of both the indexes. What are the both the indexes? One is 5, one is 4. Minus of minus 1, which is going to be 4 plus 4 plus 1, so which is going to be 9. So when you are here, so you got the output as 9. Till now it's clear now? Now when you come here, so what is going to happen, tell me please?
The
Out of
invalid
bounds.
last
The
index will
last
change.
invalid index is going to be changing, right? So that again it is going to be 6 and you should continue. That's a mistake we did. Now when you come here, so what is going to be min index now? 7, right?
Will change
7.
And again, yeah, when you come here, min index is 7 and max index is what? 5. Correct na? So now here we will, if we apply the same concept, so 9 plus math dot min of 5 comma 7 and again minus 6, so which is going to be 9 plus 5 minus 6, so you will get minus 1, so that you should not consider this case. So when you get a negative value, should not consider this. So while writing the code, you will handle that. Understood, buddy?
Yeah.
Right, because if you see, you will consider minimum value out of these two, right? So the minimum is 4, yeah, it is 4. So one is 7, another is 4, right? So you will have 4 minus 6, it is going to be 2. Minus 2 means don't decrement the earlier count, man. So when it is negative, don't consider it. So we will handle that code. Okay, so we will try to handle that through code. Now when you come here, so what is going to change?
Max
Max
index.
right? So it is going to be 8. Now it's time for us to apply the same concept. Count plus min of both the indexes 7 comma 8 minus previous last index is 6, so that 9 plus 7 minus 6, so which is 9 plus 1, you will get 10. Clear, buddy? So we are trying to handle with 3 variables, right, rather writing the complete code. So what is the time complexity here?
Order of n.
Order of n.
What is the space complexity?
Constant.
It is constant. Okay, so let's go and do that.
But you know, if we can solve this with 2 variables, why we discuss dq?
How do you get into this, buddy? How do you
I mean,
get
just
into
now we got it right with dq also.
No, that formula, right?
The formula we had derived even before having a dq, right? dq is just to keep track of that mixer man thing.
Because we are learning DQ, that's why we discuss DQ.
Yeah.
No, bro, I didn't get this two pointer form, this two pointer thought. Later, I got that. Actually, I
Okay.
been through the solutions and I found that so same concept, but he applied in different way.
Hmm.
Okay, so I'm killing your brains, huh? Max index also zero and
I'm
integer.
happy that this discussion is happening in the early in the morning, not in the evening.
Mm. These are really hard problems, but once we are done with these problems, right? Next set of problems like a cakewalk. Now for us, graph, queues, heaps, segment trees, all these things, nothing. So we are getting into very hardest path. So there you will enjoy the time. Correct, na?
You told the same thing while learning DP also.
We didn't finish DP, man. So let's say if the nums of index is less than min k or nums of index is greater than max k, then what we should do? Tell me, please. You are not getting voice, huh? So it's time to
No,
continue,
no.
right?
Continue.
Yeah. Yeah, it's time to continue.
This is the mistake we did in previous code.
Yeah.
Then what we do? Uh, yeah, so if nums of index less than or equal to nums of min index, then min index is going to be index, right?
Index. Yeah.
Similarly, same thing. This seems to be easy code.
Yes, pretty much.
Okay. So what is our job now? So now we will apply. Now if it is nums of min index value is equal to min k, and nums of max index value is equal to max k, correct?
Yeah.
Then it's
Got
time
it.
for us to find out, right? So we need to see that if okay, so let me write a simple count equal count plus math dot min of uh, min index
Min
comma
index,
max.
max index. Minus of invalid index. Last invalid index.
But when it is a negative case, what? How do you handle this?
Yeah, we have to put a condition that if it's negative, don't increment the counter.
Yeah. Otherwise, you can do this math dot max of 0 comma this. So whichever is max, you can consider that. This is also work, right? This will also work, no? Perfect.
Yes, it's the same
If
thing.
if it is negative, then it will consider 0.
Yeah. 0.
Finally, you will return count. Time limit, why are we not incrementing? We are incrementing. Is there any problem with internet or this?
Could be internet. Lit code will not be slow for such long time.
Are our code making lead code down? Okay, it was fine. Let's run. Submit. Yeah, that's it for today. There is a wrong answer, man. I think you will answer this. Let's see. Wow, beautiful test case. White failed. White failed for 4-3, buddy. 4-3 it failed. And max k, min k both are same, but it failed. It was giving 0, but expected 1.
We have
Where is this guy? Okay. So 4-3. Let me fix that. We'll continue, then we'll go on to the next index. Okay, 3 less than or equal to, yeah. Yeah, it's very bad now. Did you understand the issue, buddy? He has given 4 comma 3 and min and max k both are same. 4 3 and min k is 3 and max k also 3. So why it is failing? Initially we are blindly focusing on first element as 4, right? Yes or no?
Yeah.
First element as 4.
We
So what
need to
will
check,
happen
yeah.
now when it comes to 3, right? When it comes to 3, this will not update. 3 is not greater than or equal to 4 now, so this will not update.
I think we need to begin from -1 index.
-1, if you keep -1, this will not work, right? -1, nums of -1 will not work. One is we can go with the values. If we go with values, it will work. So based on the values, we can update min and max. Other is so what do you say? How do you handle this if it is max index is equal to last invalid index, or this case? Similarly, it should be applied for min. Is this clear, buddy? If the first element is invalid, right? Then understood? Or you can make it as -1. If min index equal -1 or max index equal -1, then you will blindly take it. Clear? Huh? This is
Let's
clear.
try this. Yeah.
It should work now. Why this guy is taking too much time? Yeah, that's a yeah, if it is -1 means it is the first element, right? Then you can blindly go for it. So if you decide on first element, then it will be a problem.
Correct.
Oh, yeah, let's run.
I mean, if you go with this formula directly, then it can be a medium problem. If you go with this formula and derive it right,
Getting into this formula is tough thing. So it was submitted.
Yeah.
Why it gets into just 1% addition? Maybe due to internet or what? What is these guys did? Okay, they have written some crazy code. Okay.